Welcome to one more Flip Classroom math video. 3 tips before you start. First, you can slow down or speed up the playback if that helps you watch the video at your own pace. Second, you can pause the video anytime to jot down notes. Third, you can turn on the captions and watch my words go by on the bottom of your screen. Today's lesson covers how to use the first derivative of a function to determine if that function's graph is increasing or decreasing. And so this begins a section where we're going to use graphical interpretations of derivatives to use those derivatives to tell us things that are going on with the graph. So the first lesson in this series deals with determining whether a function is increasing or decreasing. And a key point to remember here is that a function that is increasing is going to have a tangent line slope that's positive. So that means that the function is going up as you go from left to right, and that means that any tangent line to a point on that function is going to have a positive slope. So if you remember, the derivative of a function, the derivative function, gives us the slope of the tangent line at a point. So we're going to exploit that quite a bit. So we're going to explore this function right here. This is f of x equals x to the third minus 6x squared plus 2. What I'd like you to do is pause the video and take the derivative of this function. Okay, so what we get is f prime of x is 3x squared minus 12x. That's just using our power rule on each of those terms to find the derivative. So we have f of x, we have f prime of x. So basically the way this works is that if I plug x as 1 in here, f of x will give me the y-coordinate of the point that lies on that function. If I take that same 1 and plug it into the derivative function, that's going to give me the slope of the tangent line at that point on the function. Okay, I went ahead and sketched the graph of our function. You might want to pause the video, do that on your calculator, or use Desmos, but generate a graph for your notes. Here it is, got my xy coordinate. This is a cubic function, so it's going to have some kind of an up, down, and then a back up again. It's got a local maximum here and a local minimum there, and basically that's our function. So now let's take a look at some questions we might want to ask about this. Okay, so here's our prompt. Where is the function increasing and where is it decreasing? So looking at the graph, it's pretty easy to see that it's increasing all the way up to x equals 0. And then after x equals 0, it's decreasing all the way till x equals 4. And then finally, after x equals 4, it's increasing again. Indeed, it will be increasing forever. So we can write that with interval notation. Go ahead, pause the video, and put that down. Let's see how you did. So for me, I just used the up arrow for increasing, my down arrow for decreasing. And you can see that it's increasing from negative infinity. In other words, this thing is going down forever. So that function is increasing all the way up to x is 0. And that's combined with, that's why we have the union here, that's the u for union, with the interval from x is 4 to x is positive infinity. So that's the interval over which the function is increasing. Finally, the function is decreasing only between x is 4, or x is 0 and x is 4. Notice how I'm using my curvy brackets around my 0s and my 4s. That's because the function is not increasing or decreasing at 0 and at 4. Let's take a look at that. Okay, where a function is neither increasing or decreasing is a turning point. You'll remember with a quadratic, a parabola, we just called that the vertex. But technically it's a turning point, which is where the function goes from either increasing or decreasing to the other one. So you can see we have 2 turning points in this function, here and here. In fact, this is common for a cubic function as you get 2 turning points. So now the prompt here is find the turning points. Now, if you're observant, you realize I've already given those to you here, okay? But what I want you to do is find them algebraically. And the key is thinking about the slope of the tangent line at the turning point. So, to recall, wherever the tangent line slope is 0, that's going to be a turning point in the function. So, the derivative function, this gives us the slope of the tangent line. So we want to set this equal to 0 and solve for x, and that will give us the x coordinate of the turning points. So watch this. 3x squared minus 12x equals 0. So now we just solve that for x. So go ahead, pause the video and do that. Okay, your calculator can solve this for you, but I like doing my algebra, so I went ahead and did that. First thing I did is I just divided through both sides by 4, or by 3 I should say. That gives me x squared minus 4x equals 0. I factored an x out, so then I have x times x minus 4 equals 0. Then I solve each of these two little sub-terms, and I get x is 0 for one of them, and x is 4. So these are the x coordinates of the turning points. And check it out. That's already showing up on the graph. Here's x equals 0, and here's x equals 4. Now if I take these values and plug them into the original function, I will get the y coordinates. So if I plug 0 in for x, that becomes 0, that becomes 0, so it's just 2. So that confirms this point, 0, 2. And if you do that for this point, if you plug 4 in for x in the original function, you're going to get out minus 30. Okay, so this tells us our turning points. They are the point 0, 2 and the point 4 minus 30. So that satisfies that prompt. Okay, now we're going to use what we've learned in with this kind of a diagram to indicate whether the function is increasing or decreasing. I short-circuited the whole process by just showing you the graph at first. And if you have your graphing calculator handy and you're on that portion of a test or a quiz, by all means, graph it. But sometimes you're not going to be given that. You're going to need to do things algebraically. So what I did is I drew a number line here with the x coordinates of my turning points, because the derivative function is going to be negative when the function is decreasing, when the original function is decreasing. The derivative function will be positive when it's increasing, and again, negative when it's decreasing. So we know that it's positive here, negative there, and positive there, because the slope of a tangent line anywhere here before we get to x equals 0 is positive. Between x is 0 and x is 4, tangent line slopes will be negative, so the derivative function should be negative. And so on for after 4, the derivative function should be positive. Okay, so we know this already, but pretending like we're not, let's figure it out. So, less than 0, we want to know what the sign of the derivative function is. So let's just put in -1 for that. So this would be f prime of -1 is going to be 3 times -1 squared minus 12 times -1, like that. I can already see that that's going to be positive. We're going to get -1 squared is 1 times 3 is 3 plus 12, it's going to be 15. So f prime of -1 is 15. So that means the sign, I'm not so much caring about the number, but the sign, it's positive. So I'm going to put a positive there. So that means that up to 0, this function is increasing. And we know this from our graph because we can see the function is going up to the right. Now I'm just going to pick a number between 0 and 4 to test this interval between our two turning points. So let's just pick another easy one. Let's pick 1. So now I'm going to do f of 1, and f of 1 equals 3 times 1 squared minus 12 times 1. That ends up being 3 minus 12. This is minus 9. That's negative. So I'm going to put a negative here. That means the function is decreasing between 0 and 4. Finally, at the end, I need to pick a number that's bigger than 4, so let's try 5. What the heck? So 3 times 5 squared minus 12 times 5. So that's going to be 75 minus 60, so this is going to be 15. So that's positive. So again, we have a positive there. So we now know just from this analysis that the function is increasing up to 0. Between 0 and 4, it's decreasing. And then finally from 4 on up, it's back to increasing. And again, that's confirmed with our graph. Okay, I'd like to take one last minute with this example to show you graphically what's happening. Okay, so as you recall, the black line, this is our function. This is our f of x equals x cubed minus 6x squared plus 2. It's a cubic function, so it has a local max and a local min. Those are turning points, and the slope of the the slope of the tangent line at these points is 0. Since the derivative function gives us the slope of the tangent line, then the derivative function is equal to 0 at those points. So check this out. I sketched in the derivative function here in red. This is our 3x squared minus 12x. So check it out. It passes x equals 0 right at the turning point of 0, 2. So the derivative function is 0 at the turning point on the original function. For the same point here at 4, 0, again, the derivative function is 0 because it's not up or down. Remember, the y value is the slope of the tangent line. So what we have here is, again, at the point 4, 0, the slope of the tangent line is 0 and the value of the derivative function is 0. So this graph lines up with that graph and explains what's happening. Okay, now we're going to do the same thing with a different function, only this time we're not going to look at the graph, because if you understand what you're doing, you can answer all these questions without the graph. It's super important to understand what's happening with the graph, but basically you don't need it to answer these questions. So here's our function, another cubic, x to the third minus 3x plus 4. So the first prompt, find the turning points. So if you recall from the last board, you get the derivative function of the original function, set it equal to 0, solve for x. That gives you the x coordinates of your turning points. And then you can plug those back into the original function to get the y coordinates. Pause the video and do that. All right, so what I did is I got my derivative function. This is my power rule. I derivated this function, and I got to this one. Then I set it equal to 0. I divided out by 3. I moved the 1 over. I took the square root. And so the x values for the turning points are plus and minus 1. So then I just take the x values for the turning points and plug them into the original function, not the derivative function, but the original function, and I get out 2 and 6. So my turning points are the point 1, 2 and the point 1, 6. So that satisfies that prompt. All right, so now we're going to find out where the function is increasing and decreasing. So check this out. Got my original function. I went ahead and moved my derivative function up here. So to review, where the derivative function's value is negative, the function is decreasing. Where the derivative function's value is 0, we have a turning point. Where the derivative function's value is positive, the function is increasing. So what we do is we pick some numbers to plug in for these 3 intervals. We know these are the turning points. That was at x equals minus 1 and positive 1. So we know those are the turning points. So either it's increasing out here and decreasing in here, or increasing here and decreasing in those two. So we have to do a few tests. So I want you to pause the video, maybe look back through your notes, figure out how we do those tests, and do them, and then come back. Okay, so I just picked a point that's less than -1. So my first test here was I put -2 into f prime, not the original function, and I get out 9, which is positive. So the function is increasing to the left of -1. Then between -1 and positive 1, 0 is a great number to plug in. I plug that in, I get out -3. So that means the function is decreasing between -1 and positive 1. Finally, when f is 2, or when x is 2, I plug 2 into the derivative function, and I find out at that point the slope of the tangent line is 9. It's positive. So the function is increasing there. So that's how you can answer the question about when is this function increasing or decreasing. Now we're going to do one last prompt here. And this is a typical IB type prompt. Here it is. Hence, sketch f of x. So you just generated a whole lot of info there for your sketch of f of x. So go ahead and pause the video and make your best sketch, the best label you can do, and put that down and then come back. Okay, here is my sketch of f of x. What I did is I grabbed my points. I have my turning points from one of the last few boards. The first turning point is -1, 6, and the other turning point is 1, 2. So I marked those off from -1 to 1, and then I also knew from testing, when I tested whether functions were increasing or decreasing, I knew that when x is 0, y is 4, so I put that point in there. And then I remembered that my function is increasing here, so I made my curve go up to the turning point. The function is decreasing there, so I made the function go down to that turning point, and then finally the function is going up again, so it's increasing there. So I used my information to create a quick little sketch that's pretty darn accurate. All right, let's do one last problem. So check our function out. F of x now is 1 over the square root of x plus 1. So because we have a square root function, something is going to go on here that's going to limit our answers. So in this process, what we're going to be asked to do is find any turning points and intervals where the function is increasing or decreasing. So our first step, find the derivative function for this function. So pause the video and do that. Okay, here are my steps to finding the derivative function for f of x. So first I restated this so I could apply the power rule. X plus 1 under the square root sign is the same as x plus 1 to the -1/2 power. I brought it up from the bottom of the fraction, so now I can apply the power rule, which I did in this step. So I brought my -1/2 down, and I decreased this by 1 to get to -3/2. So there's my derivative function. Now I went ahead and simplified that so I could look at it and evaluate it. So check this out. -1/2 is just outside, so I left the -1 on the top and brought the 2 down. So then I have x plus 1 to the 3/2 power. Now what that is this is the square root of x plus 1 to the 3rd power. So I wrote that this way. Now the reason for that is that this you can look at and you can evaluate for turning points and for increasing and decreasing. So pause the video, make sure you know how to do these steps. This question has come up in the past where you've been required to find the derivative. That's the derivative, but that's not a super useful form of the derivative. You need to take it down to here so you can start seeing what's going on and what you can, and in this case, you can't do. So, first prompt, find any turning points. So I want you to pause the video and look at that, and remember setting the function equal to 0 and solving for x to see if you can find any turning points. So do that. So hopefully, when you looked at this, you realize this function can't be 0, okay? First off, you can't make x less than -1 because then you're going to have a negative number under the root sign, and we're in a situation where the function is undefined. So if the function has to be bigger, -1 or bigger, actually bigger than -1, then we're going to have the root of a very small number, and we're going to have that cubed and then multiply by 2 under -1. So this is going to stay negative. No matter how big you make the bottom here, this negative on the top is going to stay negative. So two things come up here. First off, no turning points. But we do have one interesting point, and that's when x equals -1, because that's our boundary condition. We can't actually be -1 because then that makes the bottom of this fraction go to 0 and we have an undefined situation. So I'm going to make my number line. There's only one point of interest, and that's -1. And over here we have undefined. Make my dashed line. And here we have negative. Because whatever happens, this is going to be negative. So this function is decreasing. It starts at -1, x is -1, and then it just gets smaller forever. There's no turning point, and there's no increasing segment. So that would answer that question. Now, what I'd like you to do is pause the video and make a graph and come back. Okay, so here's our function, 1 over square root of x plus 1. So in this case, x can't be -1 or smaller. If it's -1, we have a divide by 0 problem, so it's undefined. And if we have smaller than that, it's also undefined because we can't take the square root of a negative number. So this function exists only from a little bigger than -1 forward for the x value. So I went ahead and pulled up the graph and check this out. Here is what I get. I have a vertical asymptote at x equals -1. So as x gets closer and closer to -1, the function is increasing crazily, but it will never allow us to put in -1. Similarly, as x gets bigger and bigger, the function is going to approach 0. When x is 0, the function's value is 1, because then we have the square root of 1 over 1, so that's just 1. So this gives you a feel for how that graph works, how it relates. Remember, this is the slope of the tangent line at the point. So we had no turning points, no place where the slope is 0. And you can see from the graph, there's really no place where the slope is 0. It's approaching that as this line approaches the x-axis, but it never gets there. So we never have a 0 slope, we never have a turning point. Also, check it out. We have undefined when x is less than -1 or less, and we have negative, the value of the derivative function is negative when x is greater than -1, so that means it's decreasing. So check it out, my function is decreasing. In fact, this function is only undefined or decreasing. That's the limits of this function. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.